This is an example of the fact that the Cayley table of any finite group gives you a Latin square. So here we're looking at the dihedral group D8. Okay, so that's the rotations and reflections of a square. So R0 is the identity, R1 is a quarter turn anticlockwise, R2 is a half turn, R3 is a three-quarter turn. Then S0 is a reflection across the x-axis, S1 is a reflection across the line x equals y, S2 is a reflection across the y-axis, and S3 is a reflection across the line x equals minus y. Okay, and the rules of the group structure are like this: Ri, Rj is Ri plus j, etc., where I plus j is supposed to be interpreted modulo 4, and we get the rest of the relations like that. Okay, and so works out that if we this is a Latin square, so if we look at every row and every column contains every element of the group exactly once. So here we've marked all the R1s, and you can see that every row contains precisely one R1, and every column contains precisely one R1. And similarly, we could do the S3s. So because it's a group, you kind of get some quite nice regular patterns to it. Here's all the S3s here, here, and here, and you can see every row contains precisely one S3, every column contains precisely one S3, and it's the same for S0 or S1 or any group element. And similarly, if we look at any column here, you can see you've got R0, R1, R2, R3, S0, S1, S2, S3. Every element of the group occurs precisely once in this column. And similarly, if we look in this row, we've got R0, R1, R2, R3, S0, S1, S2, S3. Every element of the group occurs precisely once in each row. We're saying that this Cayley table here is a Latin square, and there's a fairly simple proof that, in fact, if you do this with any finite group, you'll always get a Latin square.